Now another important one is radius of orbit. Now to calculate the radius of orbit, we have to use the general mathematical expression. So Rn is equal to A naught into N square by Z in angstroms. Here A naught is equal to 0.529 angstroms of Bohr's atomic radius. Right? Now here this N is the number of orbits. N is the number of orbits. And Z is atomic number. Then you have to use Rn is equal to 0.529 into N square by Z mathematical expression also. Now this radius has some units. Those are very, very important. You have to remember these units. Now 1 angstrom is equal to 10 power minus 8 centimeters or 10 power minus 10 meters. And 1 nanometer is equal to 10 power minus 10 7 centimeters or 10 power minus 9 meters. Then 1 picometer is equal to 10 power minus 10 centimeters, 10 power minus 12 meters. You have to remember these mathematical, these units, these values of units, right? Next, dear students, this model is very important and basic model, and this was given in the previous examination. That is, the radius of which of the following orbit is same as that of the first Bohr's orbit of hydrogen atom. So given options are these. Now we have to calculate the first one. Then Rn means first orbit. First orbit of Bohr's orbit is 0.52. First we have to calculate this one. R is equal to 0.529 into N value means first orbit 1 by Z. Hydrogen Z is 1. Right? Now on simplifying we will get 0.529 angstrom. This is the value of first Bohr's orbit of hydrogen atom. In these options, which of the following orbit has same value? Then you have to analyze these options first. A, helium plus. Now N is equal to 2. N is equal to 2. Now R2 is equal to 0.529 into N is equal to 1. That means 2 square. 2 square. Right? Because the formula is Rn is equal to 0.529 into N square by Z. So that by Z, Z means helium. Helium atomic number 2. Then that is equal to 0.529 into 4 by 2. It is not equal to this value. That's why it is not correct option. Then you have to analyze the B option. B option is lithium. That is R2, N value 2. That is 0.0529 into N value 2 means 2 square by Z of lithium 3. Then it is not equal to 0.529. That's why this option is also not correct. Now next one, C. C is the lithium 2 plus ion. Li 2 plus ion. Then here given orbit 3, that is equal, N is equal to 3. That is 0.529 into 3 square by lithium atomic number 3. Now it is also not equal to 0.529. And now fourth option D is beryllium ion Be3 plus N is equal to 2. Right? Now R2 is equal to 0.529 into this is 2. N is equal to means 2 square by beryllium atomic number 4. Then 2 square is equal to 4. 4 cancel. Then that is equal to 0.529 angstroms. Right? This is the correct answer. Now Bohr's first radius orbit is 0.529. Now the option is D option is correct. So this is the way to analyze the given options. Right? Now another radius question also given in the previous exam. That is, if the radius of the third Bohr's orbit of hydrogen atom is R3 and the radius of fourth Bohr's orbit is R4, then what is the relation in between them? Then first you have to write the mathematical expression. R3 is equal to 0.529 into n square by z. Similarly R4 also. R4 is equal to 0.529 into n square by z. Now here R3 means third orbit. That is 0.529 into 3 square by z. Then R4 is equal to 0.529 into n is equal to 4 square by z. Z is equal to 1. Then R4 by R3 is equal to 0.529 into 4 square means 16 by R3 0.529 into 3 square means 9. Right? Both z value is equal to 1. Right? Now 0.529 cancelled. Then R4 by R3 is equal to 16 by 9. R4 is equal to 16 by 9 R3. This is the correct answer. Now in options, the B option is the correct. So B option R4 is equal to 16 R3 by 9. 16 R3 by 9. Now here answer also R4 is equal to 16 R3 by 9. Then B option is correct. Dear students, energy of orbit, these mathematical expressions also very important. So you have to remember these mathematical expressions in different units. So first one is En is equal to minus 13.6 by n square, that is in electron volts per atom. And here another one is En is equal to minus 2.18 into 10 power minus 18 by n square. This is in joule per atom. If we calculate in joules, we use this mathematical expression. Right? Now another one, En is equal to minus 2.18 into 10 power minus 11 erg atom. If you calculate the energy of nth orbit, then you have to give this ergs. We use this mathematical expression by n square. Right? Next, another important mathematical expression is, that is En is equal to minus 1312 by n square kilojoules per atom. We use kilojoules per mole, not atom, mole. Then we use this mathematical expression. right? If we calculate in kilocalories, then En is equal to minus 313.6 by n square kilocalories per mole. This mathematical expression is used. So these are very, very important. You must and should remember. Then here you have to remember one more. Energy expression. Energy expression. For hydrogen-like ions, that means hydrogen has only one electron, then these ions also having only one electron in their valence shell, right? So examples are helium plus, it has two electrons and it loses one electron, has only one electron. Similarly, lithium 2 plus ion, it also has only one electron, and beryllium 3 plus ion, it also has only one electron. So when they give these ions, we use the general mathematical expression En is equal to EH, energy of hydrogen, energy of orbit of hydrogen atom, into Z square by N square. Z square means Z is atomic number. And N is the number of orbits. N is equal to number of orbits. So N is equal to 1 first orbit, 2 second orbit, like that. Then we have to use this general expression to calculate hydrogen-like ions. Hydrogen-like ions means they are having only one electron, right? These are very, very important. Dear students, you must and should remember these mathematical expressions. They are very easy. Now energy calculations. So this question was given in the previous examination. What is the energy of possible excited state of hydrogen atom? Then how to calculate now? Here you have to use general energy mathematical expression. En is equal to minus 13.6 by n square into Z square electron volts. This mathematical expression is used to calculate the energy of orbit. Right here in this problem, the possible excited state means, here you see this is the ground state, second orbit, third orbit. Now here electron is in this orbit. Now when electron in excited state, it jumps to this orbit, then it is known as first excited state. First excited state energy level. Right? Now when it jumps more absorbs more energy, it jumps to this next orbit, and it is known as second excited state energy level. Then in this problem, excited state, possible excited state, first one is the possible excited state. Now N is equal to 2, Z is equal to hydrogen 1. Now we have to substitute these values in general mathematical expression, that E is equal to minus 13.6 into Z is 1 square by N square is 2 square. Then that is in electron volts. Now E is equal to minus 13.6 by 4. On simplification we will get minus 3.4 electron volts. Now in these given options minus 3.4 electron volts, then this is the correct option. First option is the correct. Now dear students, so another important problem given in the previous examination, that is the ground state energy of hydrogen atom is minus 13.6 electron volts. The energy of second excited state of helium ion in electron volts is, right? So when we analyze the options, so we have to calculate by using this data. Right here, the general mathematical expression is, that is En is equal to the minus 13.6 electron volts into Z square by N square. Here, helium ion is given. The helium Z value is 2. Helium ion is given. Helium Z value is 2. Right? N. So here the ground state energy of hydrogen atom is 13.6 electron volts. The energy of second excited state, already we know, this is ground state, first excited state, second excited state. 1, 2, 3. The first one is ground state and second one is first, when electron jumps from ground state to second energy level, then that is treated as first excited state energy level, and this one is second excited state energy level. Right now in the question, the energy of second excited state means N is equal to 3. 3 is the second excited state. N is equal to 3. Z is equal to. N is equal to 3. Z is equal to. Now you have to substitute these values in this mathematical expression. So that is E is equal to minus 13.6 into Z is the 2 square by N square means 3 square. N square means 3 square. Now that is equal to minus 13.6 into 4 by 9. 3 square means 9. On simplification we will get minus 54.4 by 9. Now by dividing this value with 9, then we will get minus 6.04 electron volts. Now in options, third option C is the correct option, minus 6.04. So these are the very important, that's why you must and should remember these problems. Hydrogen spectrum is also very important. Hydrogen spectrum. So it has 5 series of spectral lines. 5 series of spectral lines in various regions. So first one is Lyman series. Lyman series. So in that N1 value is equal to 1. That means the electron jumps from higher energy level to first energy level. Then N1 is equal to 1. So N2 is equal to, next numbers belong to N2 value, right? That is 2, 3, 4, 5, etc. That means N2 is equal to means first spectral line in Lyman series. N2 is equal to 3 means second spectral line. 4 means third. 5 means fourth, like that. Right? These lines are appeared in ultraviolet region. Ultraviolet region. Right? Second series of spectral line, Balmer series. In Balmer series, N1 is equal to 2. N2 is equal to next number 3, 4, 5, 6, etc. Here you remember N2 is equal to 3 means first line, 4 second, third, fourth, like that. And these are also denoted by H alpha, H beta, H gamma, H delta. H alpha means N2 is equal to 3. H beta is equal to N2 is equal to 4. H gamma means N2 is equal to 5. H delta N2 is equal to 6, like that. So it is appeared in visible region. Visible region. These are appeared in visible region. And third one is fashion series. Fashion series. In this, N1 is equal to 3, N2 is equal to 4, 5, 6, 7, etc. These values are very useful to calculate the wavelength of spectral lines. Right? Here, N2 is equal to 4 means first line in fashion series. 5 second line, third line, fourth line, like that. This series is appeared in near infrared region. Near infrared region. Okay. Next, fourth one is bracket series. Bracket series. In bracket series, N1 is equal to 4, N2 is equal to 5, 6, 7, 8, etc. That means this is the N2 is equal to 5 means first line in bracket series, second line in bracket series, third line, fourth line, like that. Okay, this series is appeared in near middle infrared region. Middle infrared region. Right? Next, fifth one, the last one in these 5 series are there. In last 5 series is fund series. Fund series, here N1 is equal to 5, N2 is equal to 6, 7, 8, 9, etc. So here these spectral lines are obtained when electron jumps from higher to 5th energy level. Right? These series of spectral lines are appeared in far infrared region. These are the important spectral series of lines in hydrogen spectrum. Then how can we calculate the wavelengths or wave number of these spectral lines? Then we use the mathematical expression. So that is equal to, that is nu bar is equal to 1 R into 1 by N1 square minus 1 by N2 square. So these values are, these this mathematical expression is used to calculate nu bar. So nu bar is equal to 1 by lambda, reciprocal of wavelength. Then we can use nu bar is equal to 1 by lambda is equal to r into 1 by n1 square minus 1 by n2 square. N1 is the series of spectral line. If it is Balmer series, N1 is always 2. N1 values are constant. And if it is Lyman series, N1 is equal to 1. Always. Balmer series, N1 is equal to 2. Fashion series, N1 is equal to 3. Bracket series, N1 is equal to 4. Font series, N1 is equal to 5. Then by using this mathematical expression, we can calculate the wavelengths or wave number of spectral lines. Dear students, in hydrogen spectrum, this model of problem was given in the previous examination. So that is the wave number of the emission line in the Balmer series of hydrogen spectrum is. He asked wave number. Now you have to use the first mathematical, you have to write the first mathematical expression, that is nu bar is equal to 1 by lambda, that is equal to r into 1 by n1 square minus 1 by n2 square. This is the mathematical expression to calculate the wave number or wavelength of spectral lines in hydrogen spectrum. Now here given problem is the wave number of emission line in the Balmer series. Now in Balmer series, N1 is always 2 because the electron jumps from higher energy level to second energy level. Then a series of spectral lines are appeared in visible region. So that series is known as Balmer series. That's why N1 is equal to. Here N2 is equal to next lines 3, 4, 5, next numbers 3, 4, 5. Then 3 is the first line of Balmer series. N2 is equal to 3 means first line in the Balmer series. That is also called H alpha line. Right. Now in this R is equal to Rydberg constant. Rydberg constant value is equal to 109,677 centimeter inverse. This is the Rydberg constant value. Now here you have to substitute these values in this mathematical expression. Now he asked only nu bar. Nu bar is equal to r into 1 by n1 square means 2 square minus 1 by n2 square means 3 square. Right? Then nu bar is equal to r into, this is, on simplifying this, we will get 1 by 4 minus 1 by 9. Then nu bar is equal to r into 9 minus 4 by 36. 4 9 is 36. Then we will get r into 5, r 5 by 36. Right? R 5r by 36. Very simple mathematical expression. Right? In these options, the first option is correct. 5r by 36. 5r by 36. So this is the correct answer. Very, very easy. Dear students, these problems are very, very easy. Right? Now dear students, in hydrogen spectrum, another one important problem was given, that is the ratio of the shortest wavelength of two spectral series of hydrogen spectrum is found to be about 9. the spectral series are. So these options are given. Right? Now you have to calculate these this problem by using one simple mathematical expression of hydrogen spectrum, that is nu bar is equal to 1 by lambda into 1 by lambda is equal to r into 1 by n1 square minus 1 by n2 square. Right? Now you have to write first n1 and n2 values. So right now here n1, to identify the shortest wavelength of spectral lines, two spectral lines means shortest wavelength in any spectral line, shortest wavelength, that is n2 value is equal to infinity, that is infinity in any spectral series. Right? Now, so in this option they are given Lyman series, Bowman series, Fashion series, bracket and Fund series. Right? First step, Lyman series. In Lyman series, nu bar is equal to 1 by lambda is equal to r into 1 by n1 is equal to 1 for in Lyman series, n1 is equal to 1. Right? n1 1 square minus infinity square. Then that on simplification we will get nu bar is equal to 1 by lambda is equal to r. Right? Now this is the value for Lyman. In Balmer series, same in similar way we can calculate. So nu bar is equal to 1 by lambda. This is Balmer series. This is Lyman Balmer. Right? That is equal to r into 1 by Balmer series n1 value is always 2 square minus 1 by infinity square. Then we will get nu bar is equal to 1 by lambda b. Balmer series is equal to r into 1 by 4. 1 by 4. R by 4. This is Balmer series. Next series is Fashion. In Fashion series, so you have to calculate similar way. Nu bar is equal to nu bar Fashion P. Right? B. In Fashion series, nu bar is equal to 1 by lambda P is equal to 1 by Fashion series n1 is equal to always 3. Right? So n2 is equal to infinity. 3 square minus 1 by infinity square. Then we will get nu bar P is equal to 1 by lambda P is equal to r into 1 by 9. 3 square means 9. Right? R by 9. This is your Fashion. Next bracket. In bracket series, that nu bar B is equal to 1 by lambda B is equal to r into 1 by r into 1 by bracket series means n1 is equal to 4, n2 is equal to infinity in all cases. Right? 4 square minus 1 by infinity square. Then we will get nu bar is equal to 1 by lambda is equal to r into 1 by 16. R by 16. This is the value for in bracket series. Next, last one is Fund series. In fund series, nu bar P fund is equal to 1 by lambda P fund is equal to R into 1 by, here N1 is equal to 5, right? N1 is always constant, 5 square minus infinity square, N2 is infinity for shortest, shortest wavelength, right? Now infinity, then we will get nu bar fund series is equal to 1 by lambda fund series is equal to R by 25. Now dear students, in Lyman series, nu bar is equal to 1 by lambda is equal to R. This is the first one. Balmer, nu bar is equal to 1 by lambda is equal R by 4. This is second one. And fashion series. And fashion series, nu bar is equal to 1 by lambda R by 9. This is 3. In bracket series, in bracket nu bar is equal to 1 by lambda is equal to R by 16. This is fourth one. And in fund series, nu bar is equal to 1 by lambda is equal to R by 25. This is the fifth series. These are the values of shortest wavelength of these 5 spectral lines. Now here in the question is the ratio of the shortest wavelength of 2 spectral series of hydrogen spectrum is found to be about 9. The spectral series are. That's why you have to take first one and third one. Then nu bar of Lyman series is equal nu bar of Lyman series by nu bar of fashion series is equal to 1 by lambda of Lyman by 1 by lambda of fashion. That is equal to Lyman R by fashion R by 9. Then nu bar is equal, nu bar Lyman is equal, nu bar fashion is equal to. Dear students, this is very easy, but somewhat lengthy, right? But very easy, definitely. 1 by, then we can lambda P by lambda L is equal to 9 by 1. R cancel. Then the ratio of wavelengths, that lambda P by lambda L is equal to 9. That is 9:1. Now in the option, correct one is Lyman series and fashion series. Then first option is correct. Then these ratio of the shortest wavelength of these 2 spectral lines is equal to 9, Lyman and fashion. So it is very important. You must and should remember. Very easy also, dear students. Dear students, now another important concept is given in this. For the Balmer series, in the spectrum of hydrogen atom, nu bar is equal to RH into 1 by N1 square minus 1 by N2 square. The correct statement among the first to 4 options are, right? So given statements are these, right? By analyzing these statements, first you have to know the concept on this. That is very important, dear students, very easy also. First one, energy increases or wavelength decreases. That means energy and wavelength inversely proportional. If energy is more, wavelength is less. If wavelength is more, energy is less. Energy increases or wavelength decreases. Wavelength decreases in the number of spectral lines in the same series. Energy increases or wavelength decreases with the increase in the number of spectral lines. That means with the increase of number of spectral lines, energy increases or wavelength decreases. Energy increases or wavelength decreases with increase in number of spectral lines. This is one important point you must and should remember. Next, another important one is the energy difference. The energy difference between the following two successive spectral lines or two consecutive spectral lines, right? Now that is in the order E2 minus E1 greater than E3 minus E2 greater than E4 minus E3, like that, right? Energy difference between the following two successive lines is E2 minus E1 is greater than E3 minus E2. Difference in between third and second, and difference in between fourth and third, then energy decreases. So energy difference between the following two successive lines, E2 minus E1 always greater than E3 minus E2 greater than E4 minus E3. You have to remember these two important concepts. Now by using these concepts we have to analyze the options. The wavelength decreases, the line in the series converge. So it is a converge means they come close. That means wavelength decrease means energy is more. This option is also correct. The integer n1 is equal to 2. The integer n1 equal to 2. In Balmer series, n1 is equal to 2. That's why it is also correct option. And third one, the lines of longest wavelength corresponds to n2 is equal to 3. Right? It is also correct. With the increase of spectral lines, then wavelength decreases. Then n is equal to 3 means first spectral line has longest wavelength. That is also correct. Then fourth one, the ionization energy of hydrogen can be calculated from wave number by these spectral lines. No, this is not related to this. That's why it is not correct. So only first, second, third options are correct. So you have to analyze like this by using these two important concepts. You must and should remember these two important concepts. Then we will get correct answer for this type of objective bits, right? Next, another important problem is when the excited electron of a hydrogen atom from n is equal to 5 drops to the ground state, the maximum number of emission lines observed are. These are integer problem, and now you have to calculate the number of spectral lines by using number of spectral lines is equal to n into n minus 1 by 2. Here n is equal to 5. N is equal to 5. Then that is equal to 5 into 5 minus 1 by 2. That is equal to 25 minus 5 by 2. That is equal to 20 by 2. Then we will get 10 spectral line. This is simple and easy. You have to remember this. Dear students, this type of questions are very helpful for writing JEE Mains exam. If it is useful to you, please subscribe.